Oh, hi there. We're glad you're watching one of our virtual lunch presentations. We have a lot of good information that we've been accumulating over the past several years, and we invite you to look down just below here and hit the subscribe button, and the little bell will give you a reminder of when our next presentation is published here on the YouTube channel. Thanks for your support. Appreciate it. Our main topic today: test gear that will not break the bank. And I think I'm going to start by inviting Danny Boyer to join us. Danny is down there in Texas. He is station owner. He has a communications business in Dallas. He is well known by broadcasters all over the state. And for a while, you were feeding your station in El Dorado from Dallas, if I remember correctly. You may still be doing that, I don't know. But given that and all that activity, you want to know what's going on. And I appreciate the fact that you started sharing with us some of the tools that you've been using, and some of them are pretty inexpensive. So Danny, we'll start with you here.
Okay, I'm going to get back over here to where I'm at. I lost myself here. Clicked on something here. Okay, there we go. I clicked on one too many things. You're right. As Barry said, I'm Danny Boyer. I'm out here in West Central Texas. I own several stations out here. And we feed everything from 2 different studios out here. I also own a business up in Irving, Texas, which my wife and I started 49 years ago. Unfortunately, she passed away in February the 3rd, 2018, after battling stage 4 breast cancer for 12 years. Large part of the work that we do in the Dallas-Fort Worth area is federal government, so I'm not sure I'm as well known here on the commercial side as I am on the federal government side, but we do work for various governmental agencies, FBI and Secret Service and ATF. I do special projects for the FAA from time to time. I mentioned to Barry the other day, I was a little busy last week. I was helping to fold bills and stuff of that nature, trying to get them in the mail before the holiday. I have been experimenting, and I'll get into that a little bit, with solar. There was some discussion last week about solar. Which station was that, Barry, out on the West Coast?
Which station for which?
Which had the solar panels?
Oh, we were talking about KGO, which
Okay.
is no longer doing that.
Yeah, I understand. Well, I am doing that, not at the station, but I'm doing that at my house, experimenting a little bit. And for those that you don't know, basically the IEEE standards as far as solar inverters require you to have grid voltage tied to a grid, and it requires a grid to be active. In other words, you've got to have 240 volts coming in and tied to the output of the inverter for it to actually generate any AC to you. So if you have a solar setup at your house, for example, and all of a sudden the town or your block loses electricity, even though it's in the middle of the day, you don't have any electricity coming out of the inverter. Of course, that's part of the standard, and that's to protect the technician who may be down the street, whatever, may be working on a pole, transformer or something, from backfeeding 240 into the line, and he may be working on the primary at 7,200 volts up there, and all of a sudden you see 7,200 volts coming in. That's not too good for him. So again, all the solar inverters that are manufactured are required to go offline whenever there is no AC coming in. More about that little situation later. I ran across a couple of things, and I'm going to show you here one of them if I can get it up here close. Get zeroed in. This is a little device that I ordered off of eBay. I actually ordered two different ones. I'm going to bring it up here. Let's see. There you go. There, Mary has it. Okay. That's actually it on eBay. I paid $17 for this thing, believe it or not. I think it's like $22. And I offered the guy $17. It was a guy in the United States because I didn't want to have to wait on it to come from China. This little gadget's kind of unique. It works from, I think, 90 volts up to 300, something of that nature. Let me look here on the back of it. It says 80 volts to 260 volts. And so it accurately measures, I've actually tested it, and actually measures the voltage that you have across the line. And it comes as a little rinky-dinky current transformer that's supposed to read up to 100 amps. And with that unit, you can actually read the voltage coming off the line, etc. The thing I was interested in was to read the voltage coming off the line and read the voltage coming out of the inverter, how much current we were coming out of the inverter, how much current we were coming off the line, and et cetera, et cetera, et cetera. And I'm going to build up a little panel, implement that in it. I will say this, in my test, I have tested this. It's right on the money, and I'll show you in a minute. I actually have this thing plugged in, and this is actually live. Here you can see if I'm getting zeroed in. Once again, got the reflection. We have 245 volts coming in here on the primary, on the 240 single phase. And as you see right now, we are not drawing any current. I've also rigged up, don't laugh at my setup here. I took a couple of traffic light bulbs, just like you would run in side light. These are 8,000 hour bulbs. Believe it or not, I think the old standard was 116 volts. I don't know what the standard got changed to, but these are actually 116 watts. These are 135 watt bulbs. So I took a couple of them, I tied them in series here, as you can see, with this, and get zeroed in here. And don't laugh at me, but I have a 120 volt plug on it because I have 220 volt bunch of plugs laying around. So with this extension cord right here, believe it or not, I have the little device plugged in here, as you see. And I'm going to plug in this light bulb, these lights, if you will, which is going to, they're in series. So we have 135 watts times 2. You can see my little lash up here temporarily. But I'm going to take this current transformer, snap-in current transformer, and I'm going to put it around, if you can see there, if the light's not too bad. I'll get zeroed in. Light's pretty bad there. I'm going to put that down, but you can actually see with this little device I paid $17 for, zeroed in, you can actually see the current that is being drawn by those two light bulbs. And it's right on the money. So I haven't measured it with anything more than the two light bulbs. Zeroed in a little more. What does it say? It's actually, I think 1.1 amps, but it's actually reading it at 1.083. You'll also look down in the lower left-hand corner. It shows you the amount of power that you're drawing. I think it shows 255, 265 watts, something of that nature I'm looking at on the screen here. The other thing that I was definitely interested in was the frequency, measuring accurately of the frequency. And the frequency is, as you see, is 60 hertz. Now, in checking this, I'm going to plug in my handy dandy fluke meter that I carry around. And let's see here, if I can hold this thing up here. There's actually the voltage that the device is measuring. That's actually measured with the fluke. So it's 244.8, and I believe it said 245 on the screen. We'll look at it again, if I may. Yeah, it says 245. Okay. I've measured the current compared it to the fluke. It's right on the money. And you'll notice a while ago that the frequency showed 60 hertz on the little meter here, little $17 meter. And there's the frequency of the line coming in on the 240 single phase as we speak. I was looking at it a little earlier, coming from the electrical provider, it's like 59.9, so it's varying a little bit up and down. So in a nutshell, I was pleased with, turn these bulbs off. Anybody have any questions before I turn the bulbs off? They're pretty bright.
If you have a question, press your space bar or alternate A to unmute.
So, at any rate, I bought this thing to, again, have an easy way to test, and was going to build up a panel with, like I said, look at the voltage coming out of the off the line, and also the voltage coming off the inverter. You may talk about the solar now a little bit, Barry. You want to go on with something
Sure,
else?
if you'd like. If we could get to that. I think we ought to cover a few more items. Spectrum analyzer and a oscilloscope and a couple other things, and then we'll get to the solar.
Yeah. Danny, where'd you buy that meter?
I bought it off eBay. Barry, you want to bring it screen up again?
Yep.
I sent it to Barry earlier, and he brought it up there. There it is there. If you copy those words or whatever there, you can probably find it. There's a whole, Barry, scroll up just a little bit if you can. There's a whole bunch of them there. But again, I picked the one, this guy here, he was in Kentucky or something that was importing these things. And out of the 113 he sold, I bought one from him. But I did offer him $17 and he took it, so.
Danny, I got a question. In your travels looking around for this, did you find any of these things would go over 100 amps? Or anyone that you could like set what the current transformer ratio was?
Well, to the best of my knowledge, all of these cheap current transformers come out with 0.333 volts at full scale. I do have some other current transformers that are set up for 200 amps that put out 0.333. So if you took this little thing here and put a 200 amp current transformer on it, multiplied your reading times 2, that should be an accurate reading. I have not tried that myself.
Yeah, I guess I'd be happier if the widget multiplied by 2 all the time instead of me doing it until the end of time.
I understand. I haven't looked at anything more than that. We're not drawing the inverter that I have. I'll look at it in just a minute. Let me look at the sheet here. The inverter that I have I have several of them, but it's a 10,000 watt inverter. At 240 volts, it's designed to pump 42 amps into the 240 single phase. So far, I've been checking everything I've been doing against. I also have a fluke meter here. I've been checking everything against it. I should have done that a while ago. And when showing you the voltage of the fluke meter, as far as voltage and frequency. But this thing, when I'm checking with the clamp on fluke meter, it's right on the money of what this little $17 device costs, shows.
A little more expensive, but certainly nowhere near what you would have spent years ago. Someone passed this along to us a couple of weeks ago, and I thought it would fit into our discussion. It's a spectrum analyzer, handheld spectrum analyzer. And what do you think the cost is going to be on this?
$100.
No, you're pretty close. You're pretty close. if I, let's see, I gotta get rid of that X here somehow. And 76.49. It's a spectrum analyzer, 100 to 960. You had two inputs, or rather, medium frequency, high frequency, VHF, UHF, signal generator, ESD protection for $76. Now, what was a spectrum analyzer in the good old days? 7,000, 12,000, 15. Maybe you could borrow one from the guy in the TV station. Now, this is not going to be the best spectrum analyzer in the world, but it should certainly allow you to see where problems are. And I don't know if you could use this for NRSC or not. Probably not. It probably doesn't have enough.
The signal generator, it can't be used as a tracking generator either. It's either one or the other, not both. I asked that question of them.
All right. Well, that's good to know.
It stops at a gig, so you don't get to look at your the output of your satellite dish.
Mm-hmm.
Newer ones go up to 1.5 gigs. They have one that goes up to 3 gigs, but it's a lot more expensive. It's about 100.5.
I start looking at those and think you could buy those and like glue them to the front of devices, like it lives connected to a processor or a stereo generator or an STL. That suddenly, okay, I have a display that the device didn't have.
Mm-hmm.
I remember on pricing, the big HPs were like 30, 40 grand in the early 80s. I remember about 87 or 8, Tektronix came back with one that was $11,000 or $12,000, brought it to NAB, and I remember Brian King was at KLVJ in those days, and you knew they were a big station because he said, we saw it, we called Austin and said, send us a check, we're bringing one home. You know, so the golden age, I mean, it wasn't until the 90s that we hit 10 grand. And when we did all the Sprint relocation, one of the things we got from that was suddenly we needed a $3,000 to $5,000 spectrum analyzer that just every displaced user could get.
I've got a spectrum analyzer that plugged into a Toshiba laptop from the late 80s. I still have that. And then I won a tiny essay at the local ham club, so I got one for $2.
I think Leader had one that was just the guts, and it plugged into a computer, got it down to about $3,000. And a lot of people, was it Avcom or Adcom? They made a $2,000 or $3,000 one that the cable guys used.
Yeah, this one was interesting in that it used a TV tuner front end and would sweep it. That's how they did it.
One of the magazines offered that as a kit. The parts cost was about $500 or $600, but from that you'd use a cable TV tuner because it had a very wide range, and it and a couple of calibrated oscillators, and you had a serviceable spectrum analyzer for cheap.
Now, maybe you don't need a spectrum analyzer. Maybe you're looking at your audio signal. Maybe you want to check your phase. And to do that, well, you don't have to spend a lot of money. One of the options that comes up is this little product here. And this is currently available for... Here, get rid of the X there, for $197. Is that too much? Well, how about this one? Dual trace. This one is $156. And now, what I'm going to do here is in the audio may come up again, but this is free.
Top 40 Hit Clock. The beat goes on.
Top 40 Hit Clock.
And that's free for non-commercial use.
Well, you can get a free one if you buy a new Nautel NV10LT.
Yes, and you want to carry that down to your studio in order to
Well, and I
check out
think
your
external
console.
input jacks are an option.
Well, you just get on the internet and go in with the old GUI.
But I used that actually 2 weeks ago to identify a program on a local LPFM that was out of phase. It was apparently recorded out of phase on a home machine of some sort. They brought it in. Maybe they burned a CD or something. I don't actually know, but it was extremely clear from the Lizaju pattern that it was out of phase, and told the station, and I don't know if they're going to fix it or not, but now they know. That's another thing that we talked about, I think, on the broadcast list a week or 3 ago. Can you buy a mono radio anymore? Even many of the clock radios that you'll find are stereo. Gordon?
Yeah, along the lines of audio testing, if you're, shall we say, a little more into just more than just phase, but actually frequency response and whatnot, there's a piece of software called Room Equalization Wizard. Don't let it fool you. It's really an audio test set, and it will work with works on a computer and any audio interface. It actually will, as part of the setup routine, will null out the audio interface that you're using, and so that you can do it. It was originally designed for doing rooms, but it does work. My suggestion is, if you try it, it's free, and if you really like it and want to go explore a little more, there is a paid version. I think it's like $39 or something like that, that actually unlocks what they call a pro version, which actually gives you full true two-channel capability, so that you can do stereo and whatnot. And there it is. So I use it. I found that the big catch with it is that it's real time only. If you have any sort of delay between your input and output, it doesn't really work, but there is a way around it. It will read a white noise source and can interpret that. So for instance, we got a white noise test tape and use it for testing analog tape machines, doing frequency response on that. So again, the price is right.
Yep, that's true. Harold?
And by the way, I've been using it with a Behringer interface, USB interface.
Very nice. Harold, you want to talk about this? Do we lose Harold?
I had to hit the unmute button. So I first became familiar with this for use in cinemas and looking at multi-tone intermodulation distortion measurement. So they also call it spectrum contamination. And so I played with it a little bit. There is a SMPTE standard being considered for audio playback systems in movie theaters that would possibly use something like this. So anyway, it looks interesting. I also posted a thing of the visual analyzer, which is a scope, frequency counter, distortion analyzer, and so on. These are showing you impulse response and so on.
Certainly gives a wide range of items here.
Yeah, it's largely acoustic stuff.
artalabs.hr. Okay. Grady, you're up.
Unmute.
There you
I
go.
use these things at a lot of my transmitter sites. It's a little mono analog type radio, so it doesn't forget what station it's on when the power fails and comes back. It's like 20, 25 bucks on Amazon.
What's the model number?
It's a Panasonic RF-2400D. I haven't tried to use it at an AM site yet. It's got the typical loop stick antenna in it, but the FM is one of those. So if you're at a transmitter site, just don't put it up and it seems to work fine.
I sent you one, Barry, just a minute ago.
$28. And
Yeah.
this is a good check. I think every station should have at least one mono radio somewhere. All right. Anyone else have a little piece of equipment that they like? Someone earlier mentioned the kilowatt, and I've got a couple of these. One of them is actually built into a power strip. Another one is built into a Wi-Fi so that you can actually access it from wherever you want to. This is a what they call their 4400 for $29. You can plug in and you can find out volt, amps, watts. Not quite as accurate perhaps as that Fluke that Danny has, but fairly accurate to let you know if you're in a brownout situation or if your wall wart is pulling power when it shouldn't. Was that also you, Harold, that had mentioned the kilowatt, I think?
Yes, it was. And it also measures power factor and kilowatt hours and so on. So, and then watts and volt amps. So it's pretty sophisticated. They just use, I think it's a piece of wire as the current sensor in there as a resistance.
Mm-hmm. Good point. Now I've been banging on Corny Gould to come up with a list of loudness meters, but Stu has pointed out the Orban loudness meters, very easy and quick to get to. Stu, you want to say a few words about it?
My microphone is not working, I don't.
Yep, we can hear you loud and clear.
Oh, great. I just happened to play with this years ago, and it's pretty cool. I haven't used it since.
It's free.
Oh, yeah, it's free.
And as I recall, maybe Mr. Bialik can refresh us. I think it shows both regular sort of view meter and the LPF or what's it called? The streaming levels.
Yeah, it can show the loudness level in LKFS. On the third meter down to the right, you'll see a little digital number, and that'll be your LKFS. And the only thing, it's a great program. It's a little difficult to set up depending on what your how your sound card is in your computer, because you got to make sure when you're doing your loudness readings that your microphone is muted. And for some reason, they never put that in the instructions. And whenever I've used it, I've always had to make sure that the microphone is muted. Otherwise, you do not get a true reading.
There are 4 or 5 different free loudness meters on the web. And as I say, I was hoping that Corny would bring us a little list here, and that's coming.
You
He
can
promised.
also look at the Julian meter, which I know Courtney uses and John Keene uses. I use it sometimes. So it's a little more difficult to use. I've always depended on the Orban meter myself.
All right. If I'm not mistaken, this is the one here. Just bring this website up real quick. And it's free, but it's got a pro version too, doesn't it?
Yes, the one thing that is really nice on it is the graphing capability.
I'm not sure I can bring anything else up here real quick, but at least we can see that much.
Yeah, I'm sorry, I don't have it on this computer.
All right. Now, one of the things we discussed some weeks back is the importance of knowing your levels when you're on streaming, because it's a whole different show than what you're feeding your transmitter. And so something like this, or the Orban there that has the LK as well, probably good to have so that you know that you're not distorting. The levels that I see on YouTube stuff, it's just all over the place.
And Barry, the one thing that's really great about the Orban, besides giving the loudness meter readings, it gives you LRA, and this way you can make sure that you're providing some dynamic range, which will, I don't care what anyone says, if you have good dynamic range, it's more comfortable for the listener, and the listener enjoys good dynamics.
So dynamic range, that's a whole kettle of fish. There was a time there was a station in New York. I think it was running dynamic range of 0.7 dB, something like that.
They went from worst to first.
Oh, is that the one?
I think so.
Wow. I would tend to think that if they were that crunched, that the TSL would be down to 42 seconds or less. Mr. Stewart, you've got something here that you just popped up in the chat. You want to talk about that for a second?
It's a cheap alternative to things like a Power Aim or any of the Array Solutions analyzers. It's a little cheap VNA, and if you don't have strong signals coming down the line, whether it's a toy or an educational tool, it's kind of hard to say. I bought a couple of them, and I don't use it for anything serious, but it was neat to just have one that you can put in a very small travel case.
Are these work together, or are they 2 separate products?
That's 2 separate products.
Okay.
It's really the same device in 2 separate boxes. The left one you plug in your computer and you program it through the USB. The right one, they actually gave you a physical user interface. There are actually some buttons on the left one that you can't see, but this is a little more menu driven.
Yeah, I've got one of those SARC 110s and really like it. It'll also dump a CSV. So I've done a sweep of my HF antenna from, 1 megahertz to 30 megahertz, and then I can just graph R and reactance. It's nice. It'll also work as a calibrated signal generator. Output's calibrated in dBm.
Very good. What other kind of tools do you use that now, Simpson 360, they were the main frame of test gear for a lot of radio people for a lot of years, but you can buy a DVM now for $6.
260.
Danny?
Simpson 260, wasn't it?
Simpson 260?
Yeah, I think
Yeah.
you said 360.
Oh, yes, 260.
I thought, drat, I went all these years and I didn't know about a 360.
I think the Simpson 260 is still in production. They are kind of expensive. In high school, I ran telephone and teletype lines through trees all over the neighborhood and was up trees with my Simpson measuring against ground, which was a nail into the tree.
And Barry, don't forget what the test gear that most people were plagued with, but had, and those tools were very realistic.
Realistic, or you had a B&K scope. I remember buying one for $100 or so a few years back, many years back.
Was the Radio Shack brand for test equipment Micronta, I'm thinking?
Yep, it was. So there's the 260-8, still there, $400 a pop.
I think I read somewhere where up north where Simpson is, that the Amish own that company now. It's been fairly recently.
Now,
Barry,
yeah.
a lot of these tools are really great, but the one tool that most radio engineers need right now is a good network analyzer that they can trust, that has a good TDR in it. I know I carry a Fluke around with me all the time because 9 out of 10 times you're dealing with stuff on a category 5 or 6 cable, and you really need to be able to test that. You need to be able to test if you're going back and forth to a switch because everything is IP based now.
So what kind of price is that Fluke got?
Well, I'm a poor guy, so I bought mine used on eBay, and then lucked out when I helped a Fluke salesman change a flat tire, and he gave me a new one. First lesson: always be nice to a stranger. You never know what's going to happen. But I carry my Fluke with me daily and have for many years. I'll tell you what number it is because I don't even remember, but I use it. It's a 620. I know they have newer versions, but the great thing about it is that you have a time delay reflectometer built into it, so you can find the break in your cable. And remember the days when if you had to get a TDR, you'd be spending a few thousand, and now it's just a feature on a meter. It's wonderful.
Oh, thank you. I forgot where I got it, but here, I'm going to show you this real quick.
Oh, we got somebody talking. Let's see.
Nope.
It's coming from Stu.
See how we...
No, it's not. Okay. So this is the one you're talking about here, David.
Yep. I carry this around with me all the time. It's a great device. I can test, I can tell wire length, and it has saved me more times than not of something that would deal with hours with other people. I'm able to get it done in a few minutes. It's the greatest thing in the world.
Well, it's certainly something that you're not going to pick up just for one use.
The funny thing is, I have a friend of mine that picked up one on eBay for like $125. So always look at eBay because everybody likes to come up with new models, and a lot of times the change is only small features and it won't help you. The other thing is, this that I'm holding up right now, I've never seen it out, but Fluke used to give them out all the time at their trade shows. And this is a little PoE tester. You plug it in, I can tell if there's voltage on the line for any of the PoE devices in the office, which is really helpful in the studios.
So you're going to send one to each of us this afternoon?
If I could, I would.
Well, rat starkies.
I
Danny,
think
let's-
that I think those new Fluke models run about a couple $1,000s.
And Mary's going to work out a special for all of us.
Yeah, I'm seeing it here anywhere from 540 to 1700.
It depends on what you put in them. Those are some of the less expensive models, but that one I think David has a lot of the features in it. Like I think it's a more expensive one.
Like I said, it was really nice when I stopped by leaving the city one day. It turned out to be the Fluke salesman. Helped the guy change a tire. He invited me to the sales presentations and said, "Hey, you need this," and he handed it to me.
Well, they've got a lot of different tools there, certainly from Fluke, and depending upon what your task is and what you need to do, you can certainly use them and you can get things done. Danny, we want to come back to your thought here about the solar panels and the the inverters. So I'll bring this up because this is what you were telling me about. I'll scroll it if you tell me.
Okay, this is one of the brands of the inverters that's out there on the market. To the best of my knowledge, what research I've done in the last several months, this company called Solar Edge is the primary manufacturer of, let's call it residential type inverters, if you will. I have several that I'm testing. I have a SE6000H, which is 10,000 watts output continuous. We also have the biggest one that they make is at 11.4. By the way, all of these are single phase outputs. Anything from any manufacturer that is greater than 11.4 that I found, it actually goes to 483 phase. So if you have a 20 kW or 30 kW or anything of that nature, it's going to put out 483 phase, and you've got to get your step down transformer, drive transformer or something, convert it back to 240 where you can use it, at least at your house or business, whatever. I'm presently running about 12 solar panels right now. Those are 300 watt panels, and they drive one of these. This is the picture that Barry has up, is the older model. Has a display, well, I say it's an older one, I'm going to refer to as the older model. It has a display on it. And Barry, if you'll let me have the screen here just a minute, I'll bring up something here. Let's see here. It must be the same one, I'm sorry. The newer ones do not have the display on it. And you actually talk to them via iPhone app, a free app. You set it up and it basically acts as a AP, just like it would be at your wireless router. And you set your iPhone up and you connect onto it, etc. Again, if you look at this is 10,000 watts output, 42 amps. You'll notice the frequency. These are preset at the factory. You can go in and change them, but you got to have the little magic password to do that. I don't see any real reason why to do it. But these are set up to operate anywhere from 59.3 to 60.5 hertz. So when you connect it up to the grid, it looks to see what kind of voltage is coming down the grid. It basically adjusts itself to have the same voltage as what's coming off the grid, and adjusts itself to provide the same frequency, output frequency, if you will, as what's coming off the grid. I showed you that a while ago where there's a little off of 60 cycles coming into here according to the fluke meter. The 12 panels that I have, solar panels, 300 watt panels, are not near enough to run this inverter at 100%. So I will be adding some more. I've designed up a rack, if you will, that will handle. Let me get back over here if I can. Let's see, there we go. I've designed up a rack made out of unistrut, and we're fabricating one. Yeah, there you are there. Okay, that's a 3,000 watt job there. They make them in several different models, all the way from 3,000 up to 11.4. The unistrut rack I've designed will hold 3 solar panels. The solar panels basically are 80 inches tall by 39 inches wide, and it'll hold 3 of them. And this is going to set pretty well on the ground at about a 45-degree angle. I've yet to figure out the exact angle that I want, but the ultimate goal is to try to maximize it so we have maximum coverage during the winter also. So it'll be halfway. As you know, the sun is different places in the sky, whether it's winter or summer. So I'll probably split the difference. It's been my experience with the solar panels that they're pretty broad as far as the angle of the sun coming in. As I mentioned, the output of the solar panels, or it says output of the inverter, is only present if there's 240 volts from the grid coming into it. Once that 240 volts goes away due to a power outage or whatever within the city or at your house, if you didn't pay your bill, if you will, they actually shut off. And again, that's to protect the grid from voltage feeding back.
So you'd have to install a switch.
It's automatic internally. They require the electric grid providers, virtually all of them require a safety switch that they could come up and turn off or whatever from the output of the inverter tied to the grid. Normally what you do, you just take the output of this, feed it a pair of breakers, and you feed it into the breaker box. One of the things that I am working on is I'm trying this at the house now. We're ultimately going to feed one of the radio stations, probably with about 20, 30 kilowatts worth of energy. And to do that, we'll have to go to a 20 or 30 kVA per kilowatt inverter. And again, that is 480 volts, 3-phase coming out of all those.
I don't know if you're reading the comments here, but several of them say that this almost defeats the purpose of putting a solar panel up if you go dead when the grid goes dead.
Well, I agree with that. However, that's the next step, if you will. Let me go back over here and show you something. Before I started this project, let me see if I can find it here. Guess I didn't bring it up. Let me go back over here and see if I can get it. Let's see here. One of the projects that I did prior to this, and let me get over here and get this online for you. Okay, I assume y'all can see that inverter.
Yep.
This also, I found this on eBay. This is this company that builds these are actually a pretty big, large inverter and battery charger manufacturer over in China. And I sent them 2 or 3 emails back and forth, and I said, look, I'm interested in an inverter that I can run off 24 or 36 volts, something of that nature input, preferably 24. And I need that inverter to come out with a certain amount of voltage, which in this case is 245 volts. I wanted this inverter to match what was coming off the grid, if you will. Here where we're at. So, and the other thing I asked him, I said, how is your frequency determined coming out of this inverter? And the impression I got with trying to interpolate the Chinese was basically it's crystal controlled, something of that nature. Now, let me go back over here and I will show you the device, okay? This is, if I can get it up here, that's the device. And this is where it comes here. And this is the front of the device. When talking to the lady back and forth, she emailed me back and she said that the technician or whatever, the guy who was setting it up was having trouble setting the inverter that I ordered to 245 volts AC coming out of it. And she wanted to know if it would be okay to supply another inverter, which cost more money, but they were not going to charge me any more money in place of the one that I ordered. I told her that's fine, as long as I got 245 volts, 60 cycles coming out of it. And she took an extra day or so, and the technician basically took this one off the shelf and he preset it inside. I don't know whether it's microprocessor, adjustable, or there's a pot or what. I haven't been into that. But it basically delivers 245 volts. One of the other things, if you look at that page that I had up a while ago, they ask you what kind of outlets you want on it. And so they've got all these different European outlets that you can't find the plugs for over here. So I told her just put standard 120 volt plugs on. So this inverter actually is putting out 240 volts with the standard plugs. I need to paint them red to make sure that nothing else gets plugged into them, but I want to be able to easily get to it without trying to find a plug from somebody. This inverter, I've actually connected it up. It does generate 245 volts coming out of this inverter at 60 cycles. And again, I've measured that with the Fluke, and I've also measured it with the little cheap $17 meter here. It does say 60 cycles at 245 volts. I have put the two tower light bulbs, if you will, that are in series across the output. And I measured the voltage both with the little meter and the Fluke meter, and as well as the frequency, and it sits right there at 245 volts with about 300 watts worth of 250 to 300 watts worth of draw off of it.
Is it split phase between the plugs, or is it both plugs 255 or 245 volts?
No, both plugs are just wired in parallel. 240 volts, basically single phase coming out, just like it would be coming into your house. Now you may ask, why am I going to all this trouble? Well,
why are you going to all this trouble?
Well, I'm going to all this trouble because the comments that you said that were on chat, I'm trying to defeat that process. If you have a site out there somewhere that, for example, does not have voltage, grid voltage, and you want to generate your own, with an inverter like I showed you, should generate 10 kW worth of power. The problem is we have to have voltage to trick the inverter to get it to think it's tied to the grid. And that's the purpose of this little inverter here. I have not connected it up yet. My plan is to come out of it. And by the way, this is 24 volts DC. I had it tied to two 24 volt batteries. She asked whether I preferred 24 or 36 or 48, and I said I prefer 24 volts. And that's readily, easily obtainable with two deep cycle batteries or whatever. But with this inverter, I plan to trick the output of the solar edge inverter to think it's connected to the grid. I really don't want this inverter, even though it's 1,000 watts, I don't want it to supply any power to my load. I just want to have enough voltage going over there with minimal current to trick the inverter so that the solar edge inverter to see that it does have 240 volts. So that will be accomplished in the next week or two. What I'm going to do with it, coming out of this inverter, I built up a little test jig. I've got a couple of fuse holders, inline fuse holders with some 1/2 amp fuses in it. And I've got a selection of 3-watt wire wound resistors. And I'm going to start at the higher value, the highest value I have, and work downward. But I want to make sure that the inverter can see the 245 volts. The solar edge inverter can see 245 volts come out of this inverter. So it will trick it, if you will, so it can turn itself on. And of course, the load will be tied to the 245 volts output of the inverter, of the solar edge inverter, if you will.
Well, you'd need to do something like that. Otherwise, what's the better, especially if you're trying to power your radio station and the grid goes down and you go down?
Well, the purpose of that, what I was going to do was I'm going to install a relay in between the grid going back to, let's call it, to the breaker box. And that ultimately is going to be tied off of the voltage off the grid. So if there's no voltage on the grid, it's going to, that relay is going to drop out. And this, with the Form C contacts in that relay, it'll actually connect this guy up that I just showed you to the output of the big solar edge inverter.
Isn't this really essentially what generators do?
Yeah, but it takes a little while.
Without the transfer switch.
Yeah, transfer switch.
Yeah.
So Danny, if you set it up so that it was not set up as a grid tie, assuming, of course, you couldn't sell power back to the electric company if that's an option. I don't know if it is, but then you could have a transfer switch, and just when the commercial power failed, it would transfer to this.
Yes. However, on the other side of the coin is you want that inverter on all the time, so you're drawing current out of the solar edge inverter and your cells to keep the electric company's bill down. Now, if you sign up with the right provider, the one I'm signed up to for the trial here cost about 12 cents a kilowatt hour. It was on a short-term basis. I'm not interested in a long-term contract. It's 12 cents a kilowatt hour, and they pay you back 12 cents a kilowatt hour. So the objective is, like if it's your house, you want to be able to have a big enough inverter to run all the stuff at your house, the air conditioners and stuff, plus have extra current to pump back into the grid. And they will give you credit at 12 cents per kilowatt hour that you pump into the grid. Because when the sun goes down, you're going to be consuming electricity strictly from the grid because there is no electricity coming out of the solar edge inverter because there's no sun going to solar cells. And of course, the objective is to pump enough current back into the grid that you build up credits. So what you use at night will pay for the electricity you're using at night from the grid.
The electric company here tried to do away with buying back current power from the homeowners, and they had a huge uproar, and I think they've come up with some sort of arrangement here. Harold, I'm going to pop this thing up here because you sent that. Maybe you want to talk about that for a little bit.
Okay, and we, as mentioned, we do have a grid-tied system with microinverters, peak output at 3.3 kilowatts. And so I've been tracking it pretty much daily measurements for a little bit over a year here. So you can see the blue line is production, the red line is consumption, and you can see when we turn the air conditioning on. I have the same power company, I believe, as Barry, is Tucson Electric Power.
Yes.
And I wasn't here for the fight, but our current system, they do net energy billing. So it's what we pull off the grid minus what we put back on the grid, and that's what we're billed for. There's like a $25 a month minimum charge. And then if we put more back than we pull out, they put it in the bank. So we can get those kilowatt hours back later. So anyway, this is what our system is doing right now.
So is this where you've made a little money here? Is that what that's?
Yeah, you can see where the red line is below the blue line. We made a little money. I think we came into the summer with about a 10 or 20 kilowatt hour surplus in the bank, and we quickly consumed that when we turned on the air conditioning.
Do you want me to scroll up here?
Yeah, this if you go back down, there's the air conditioning is the big load here. So here's a scatter plot. If you scroll down just a little bit, you can see that it's percent from solar versus average temperature. And so if the average temperature here in Tucson is about 65 Fahrenheit, we should be doing 100% from solar. If it drops down to 58, we'll be about 125%.